Oh, what a night. Late December back in 63. What a very special time for me. All right, that's enough of that. Hello and good day to you, wonderful humans. We are going to look at Math 7 notes today for 7-3 on scale problems and some shapes. So first off, we need to talk about what a quadrilateral is. And I'm sure from that beginning of that word, that prefix there, you can see that quad is a shape. You know what? We need to add the word in closed. A closed shape with 4 sides. Because something like this technically has 4 sides, right? 1, 2, 3, 4, but it's not closed. And if I did close it, that would make it a 5th side, and that wouldn't be what's going on there. That wouldn't be a quadrilateral. So it's got to be closed. All right, so some four-sided shapes that we know of. First one usually that comes to mind is a square. Swoop. And what we know about a square is that it has 4 equal sides. And those little blue marks there that I put on each side of the square, those are like congruent marks. Ooh, big fancy word. So first off, 4 equal sides. Then we said that there's this word congruent, G-R-U-E-N-T, congruent, which is just a fancy geometry specific, like shape specific word for equal. Just means equal. And the symbol for it is an equal sign, shockingly enough, right? With a squiggly line over the top. So So a square has 4 equal sides or 4 congruent sides. And having a blue mark on each of those sides like that, a blue little hash mark or a congruent mark, tells us that all 4 of those sides are equal, even if my drawing isn't perfect and it doesn't look like that. Next up usually comes a rectangle. Rectangle being similar to a square, but instead of having 4 equal sides, it has 2 sets, or no, let me rephrase that. Opposite sides are congruent or equal. So it doesn't have 4 equal sides, but it has opposite sides are congruent. So this side is congruent to this side, and this side is congruent to this side. Notice how here with my hash marks, I used 2 on this side and 2 on this side. That's to show you that those 2 are equal to each other, but they're not equal to the bases. The bases are equal to each other, but those are different from the 2 sides there. That's what the 2 versus the 1 hash marks mean. Up next, we're going to talk about a rhombus. And that rhombus, very similar to a square, also has 4 congruent or equal sides. And the only difference from the rhombus to the square is that the rhombus is kind of slanted. That's not a very good rhombus. Doesn't have to be perfect. Let's try again, though. So something along the lines of... There we go. I always try to draw it a different way, and it makes it harder. There we go. Close enough. And again, even though it doesn't look like all 4 sides are equal, I'm going to put those congruent markings in that tell me all 4 sides are equal. And then last but not least, all 3 of these shapes, a square, a rectangle, and a rhombus, are all examples of parallelograms. And parallelograms are similar to rhombuses, where they're slanted, but more like a rectangle because not all 4 sides are equal. So again, these ones are equal to each other, and those are equal to each other. before we move on, again, here we can write opposite sides are equal. And before we move on, we need to draw the heights in to these parallelograms in my rhombus here. Because if you think about when you go to the doctor and they measure how tall you are, they don't ask you to like slant over. They ask you like to stand straight up and down. And the problem with these rhombuses and these parallelograms is that those sides right there aren't straight up and down. They don't make those 90-degree angles like they do in the rectangle and the square. Therefore, this part coming down is your height. That straight up and down, making that 90-degree angle right there. And same thing in your parallelogram over here. That height. It is possible sometimes you might see the height drawn on the outside of the triangle, or of the triangle. It could be a triangle also, but of the parallelogram. That's okay. Those are the same thing. It doesn't matter if it's on the inside or the outside. That would still be the same distance. Okay. So then, break.